balls, and then I want you to watch them and then tell me what the balls are doing, okay?
It's bouncing.
Is it bouncing?
Bouncing.
Why is it's falling? Why is it falling?
Because it's bouncing up and then falling down.
Okay, but why?
Because
Because it's
it's bouncing.
bouncing? Okay, so if I drop it from here, what is it going to do?
It's
gonna
just
bounce
going
back
to
up.
fall.
It's going to fall. Why is it going to fall?
Gravity.
It's because gravity.
Okay, do you know what gravity is?
It's like air and
Actually, gravity, we're going to write that word on the board. Gravity is the force that the earth is pulling. So when we drop this, the earth is pulling it down to the ground. And then once it gets down there, it does bounce because it is a little bit bouncy. But mostly it's just going to fall. Okay, so if I take this poster board like this, and I put the ball here, what happens? What do you think is going to happen?
It's going to roll down.
Why?
Because gravity is pulling it down.
Okay, but why doesn't it go straight? Do you think it's going to bounce?
No.
Why not?
Because there's a thing holding it up.
When something is like this, that is sloped like this, this is called an incline. And an incline is one of the most basic tools. Does this look like a tool?
no, it's a piece of paper.
It's just a piece of paper, isn't it? Well, it's actually a tool. Anytime we use something to make a job easier, it's called a tool. So, I have some inclines over here that the boys have been helping me make. Alexandra, will you pick up the rest of the balls?
I'll get one. There's also one that
Like this. This is going to be an incline. Okay, so if you roll the ball down, what do you think is going to happen?
it's going to roll.
You think it's going to roll?
Yep.
Yeah. Okay, so why did it roll?
Because
Okay, it is an incline, but it's the same reason that it dropped when I dropped it.
Gravity.
Gravity, that is correct. Okay, so can you ever make something go uphill?
Yes.
How, Josiah?
Like a car goes uphill. You can motorize it.
Mm-hmm.
You can throw it.
You can throw
You
it.
can force it.
push it up there.
Yeah.
You can push it. Yes. Okay. So all of those things are called force. So you're forcing it to go uphill, so it's working against a natural inclination to fall. So have any of you been on a roller coaster? Abby, have you ever been on a roller coaster? Okay, I have a video to show you of a roller coaster.
I know what a roller coaster is.
I'm sure you know what a roller coaster is.
I've never gone on any because they're really scary.
Aren't they really scary?
They go way up high, and I know people that have. Like Andrew.
It's not loading. Well, it's not loading, so we're going to skip this part for now. I'll show you this later. Okay, so basically what we're going to do is we're going to play with our incline, and we're going to see if we can't get our ball to go uphill. How do you think, what do you think we're going to have to do to get our ball to go up the hill?
force it.
Force it.
Or have it go downward and go up.
Okay. Okay, so if you use gravity to make something go uphill, that's called using gravitational force. If you push it up the hill, like this, then it can roll back down. So how are we going to get this to go back up if we try to get it to go up? Just
You could push it.
to push it.
You could yank it.
So do you think that we could use, oh, good thinking, Esther. Very good. All right, so how high do you think you're going to have to get this side to go up in order for it to get up and over these books?
Higher than that.
Okay. So what I'd like you to do, higher than this, how many books are here? 4? Do you think 5 books is going to be high enough?
No, it's gonna have to be like 6.
6? You think 6 books high is going to be high enough?
Mhm.
How many do you think, Esther?
More.
You think
9.
9 books high? Okay.
9
So
books would probably
we're
be-
going to call this our hypothesis. Do you know what a hypothesis is?
Yes,
Joe?
I do.
Okay, tell me what a hypothesis is.
It's like a question some discoverers ask that, like something from like the old times. So my hypothesis would be if this, so I find like old arrow and then like some other thing that I throw the arrow through, and then that's my hypothesis that it's like a game.
Okay, so it's a guess. You're guessing what something is. Okay. So we're going to make a guess as to how high we have to go on our roller coaster to get it to go up and over that other stack of books. So what we're going to do on the poster board is we're going to write our hypothesis. This is the way scientists do this, is we make a hypothesis and then we test our hypothesis. So our hypothesis is, in order for the ball to go over the second stack of books, what's going to have to happen?
You need like some more books to hold it up, or you can hold it up like that.
The first stack of books will have to be
Taller.
how tall?
About 10.
10 books tall. Okay, so now we have a hypothesis. So I would like to see you test it. Uh-oh, we better get another book then. Okay. Okay, so grab your roller coaster. you test it.
Do we just drop it?
Well, right now that is a complete incline, and I want your roller coaster to be a roller coaster so it does the bumps. Can you get your straws to look like the bumps in a roller coaster?
Does that work?
Test it and see. Okay, so what do you think you're going to have to do to correct that?
Have this a little bit higher.
Almost made it.
Okay.
Halfway.
Okay, so what did you have to do in order to make it go to over that next stack of books?
We had to balance it.
Okay. Is it curvy like a roller coaster? Okay, so I would like you to think about what you're going to do to fix that to make it like a roller coaster so that it goes down and up. You have tape, you have straws, you have a ball. Go and get straws and tape and see if you can't make your own roller coaster and see if you can't get it to do that. Can you identify any of the problems with this roller coaster? Why is it not working like the way we want it to?
Because it's not curvy enough.
Well, it doesn't go up and down, but
It's all gravity's fault.
what?
It's all gravity's fault.
It's all gravity. Put this down on the ground. But that's good. Very good. Here. Attach yours to that. I think that, here's the other thing, so you're going to
Hey.
want somehow to attach this to, so that we get that. So it has no room. Oh, that's a good idea, Alexandra. Maybe if this was taped so that it was flatter, so it doesn't, you see how it's turning? Oh, that might work with a very sharp incline at the top. How are you gonna make it stay that way?